We first made sure our stock solution was well mixed. We made sure that our meniscus was right at the top of the line. Then we took 10 milliliters of our stock solution and diluted it with 15 milliliters of DI water. We repeated this process 2 more times, taking 10 milliliters of our first dilution and adding it with 15 milliliters of DI water to create our second dilution, and so on. We then filled cuvettes with each of our solutions and filled one cuvette with water to blank the spectrophotometer. We then had our stock solution, dilution 1, dilution 2, and dilution 3. Then we pulled up the Simple Reads application. We zeroed the reader and then put in our stock solution to be scanned. We cleaned the 2 sides of the cuvette the light would be passing through, carefully placed it in the machine, and closed the lid. We then hit read and found our wavelength of our stock solution was 560 nanometers. Then we opened the scan application. We hit 0 and then blanked the machine with our DI water, carefully cleaning it and closing the lid. We named our DI water blank. Then, after setting the wavelength to 560 nanometers in the settings, we proceeded with scanning our stock, dilution 1, dilution 2, and dilution 3.
In this lab, we have quantitative data and qualitative data. Our quantitative data is the absorbance that was calculated from each of the 3 dilutions. The qualitative data being the color of the dilutions that we made. Although you could compare the colors of each of the 3 dilutions to figure out what the unknown is, it is not very accurate. So therefore, we have to calculate the absorbance of each solution and compare it to the absorbance of the unknown solution to figure out what our unknown substance is.
We finally scanned our unknown solution. Here is a shot of our final graph with all of our solutions scanned.
The Beer-Lambert law relates the attenuation of light to the properties of the material through which light is traveling. This law states that the quantity of light absorbed by a substance dissolved in a fluid transmitting solvent is directly proportional to the concentration of the substance.
Now for our calculations.